Welcome, MHP Rhino Nation, to another episode. Let's get dive deep into MHP's baby.
Yeah. Okay, welcome. Today we're plunging headfirst into some really big ideas. We're talking about life, intelligence, and consciousness. But we're not tackling them in the usual way, philosophy or pure biology. Nope. We're taking this unique angle, a functional perspective. Our guide for this deep dive is excerpts from Life, Intelligence, and Consciousness, a functional perspective, which comes from long now ideas. And our mission, well, it's pretty straightforward, but also, I think, really insightful. The core idea is this. Instead of getting bogged down asking, what is it? We're going to ask, what does it do? Yeah, we're focusing on the functions, the observable jobs these things perform. And this functional lens, as we'll see, might just cut through some old debates and maybe give you some practical takeaways.
It's really fascinating, actually, how much changes when you just shift your focus like that. By looking at function, we kind of move beyond trying to define these things by what they're made of, some kind of special stuff. Instead, we get to analyze the processes, the actual behaviors, the capabilities involved. And this gives us, well, pretty practical insights from the tiniest bacterium right up to complex human thoughts or even AI. It really grounds things in how systems operate, how they deal with their environment, what purpose they serve. It's quite liberating, scientifically speaking.
That's a great way to put it. Okay, so let's start with the first big one, life. I mean, when you think life, what pops into your head? Usually something organic, breathing, maybe moving. Specific forms, right. But our source suggests something different. It argues life isn't really a static thing, something you can just point at. It's more of a dynamic process, less like a noun, maybe more like a verb, a set of ongoing activities.
Exactly, yeah. From this functional viewpoint, life is basically defined by a specific set of connected functions. When they're all working together, that's a living system. So first up is maintaining boundaries. And think beyond just like a physical wall. It's about the constant active work needed to keep that separation from the outside world, controlling what comes in and out, protecting its internal state. Without that self-organization, you don't really have a distinct self that lasts over time. Then linked to that, you've got processing energy. This is basically metabolism, right? The continuous activity needed for survival, growth, and just doing the work of maintaining those boundaries, whether it's, eating nutrients like some deep-sea microbe or grabbing sunlight through photosynthesis. Living systems are always taking in energy and transforming it to keep things running. It's nonstop. The third big function, replication. So the ability to reproduce, to pass on information, whether it's genetic or organizational, not just making copies, it's making sure the whole functional setup, this whole way of operating continues, propagating the program of life, you could say. And crucially, there's adapting and evolving. Living things aren't static blueprints. No, they change over time. They respond to the environment. They learn, mutate, evolve. This is what lets them stick around in a world that's always changing. It ensures they last long term. Our source gives this really neat comparison. Think about a flame versus a bacterium. A flame, well, it seems kind of alive, doesn't it? It uses energy, it grows, eats fuel, it even seems to spread or replicate. But crucially, it doesn't maintain its boundary in that same highly organized, self-regulating way. And maybe more importantly, it doesn't replicate its own internal structure using some kind of code, nor does it really adapt or evolve its basic design over time like a bacterium does through natural selection. A bacterium, though, it's actively maintaining its complex boundary, constantly processing energy, carefully replicating itself, and adapting over generations. It does all those things together, integrated. That's the real difference.
Wow, that flame versus bacterium thing, yeah, that really hits home. It makes you rethink things. So it's not just about having a wall, is it? It's the maintaining, the active process, which then raises questions, right? Like, where does this put something like a really complex chemical system that self-replicates? Or even, an AI that can fix its own errors. Does this blur the lines, or does it actually help us classify what's alive beyond just biology?
That's exactly where this functional approach gets really powerful. It lets us step outside the specifics of, say, carbon chemistry or cells. When we look at, synthetic life or some self-replicating machine, the question isn't, is it organic? It becomes, does it functionally maintain boundaries, process energy, replicate, and adapt? If a system, whatever it's made of, does all these things together in an integrated way, then yeah, by this definition, it's exhibiting life. It gives us a way to think about maybe alien life or purely artificial life without being stuck on Earth-based examples. It really highlights that the doing is more fundamental than the being when it comes to defining life itself.
Okay, so from those fundamental processes of life, it feels like a natural step to think about how living things act effectively. And that brings us straight to intelligence. Now, usually when we say intelligence, we tend to think human intelligence, right? Complex problems, IQ tests, big brains. But if we shift back to that functional view, it's not really about how smart you are in some abstract sense or what kind of brain you've got. It's more about, oh, what you can achieve, what goals can you reach.
Exactly. The source defines intelligence pretty clearly as the ability to achieve goals in complex, uncertain, and dynamic environments. And that's a really key distinction because it just broadens the whole concept hugely. It's not tied to a specific kind of brain or, biology. It's about observable actions, behaviors that lead to successful outcomes, whatever system is doing the behaving. And if we break down those key behaviors that make up intelligence, well, there's learning, which is basically getting new info and skills from experience, kind of updating your internal map of the world. Then there's prediction, being able to anticipate what might happen next based on the past. This lets you prepare, not just react, like a squirrel burying nuts. It's not just hungry now, it's predicting future scarcity. Then you have planning and problem solving, so strategizing, spotting obstacles, figuring out how to get to your goal. And finally, decision making, choosing the best action out of different possibilities to reach those goals, often when things are uncertain. What's also really interesting here, and if we connect this to the bigger picture,
This definition lets us see intelligence more like a spectrum. It's about effective interaction with the world, not some simple yes-no switch. Think about a plant turning towards the sun to get more light that's achieving a goal in its environment. It's a form of intelligence. Or, a sophisticated robot navigating a messy room to grab something specific. Or even an ant colony with its sort of distributed intelligence working together to find food or defend the nest. These are all showing intelligence by achieving goals in their own tricky, unpredictable worlds. It really opens up our thinking beyond just us humans.
That is a really broad definition, powerful too. But does being so inclusive maybe risk, I don't know, watering down what makes human intelligence special? Or is that the point, to see the basic similarities? And it raises another question for me. If intelligence is just goal achievement, what about something like Fusco? Like a super optimized robot that just balances. Say its only goal is stay upright, and it does it perfectly, even if you push it. Is that intelligence by this definition, or something else?
Yeah, that's a great question. It really pushes the edges. Look, the functional perspective isn't claiming to capture everything unique about human intelligence, like our language or abstract thought. It's more about identifying the fundamental engine, the core mechanisms of intelligence that let us compare across different systems. Now, about your balancing robot example. Yes, in a very narrow sense, if its only goal is staying upright and it learns and adapts to achieve that in a tricky environment, then sure, it shows a form of intelligence. But the complexity of the goals and the environment are really what defines the level or degree of intelligence. A system with just one simple goal in a predictable world. Probably less intelligent than one juggling multiple complex goals in a chaotic, unpredictable one. So it's not just if you achieve goals, but how complex they are and how challenging the situation is. Makes sense.
It does, yeah. Okay, now let's tackle the really big one, maybe the slipperiest concept. Consciousness. This is the one people often call the hard problem, right? That feeling of qualia, like the redness of red, or what pain feels like. How does all that arise from just brain stuff? It feels so personal almost, like beyond science. But this deep dive takes a pretty brave step. It doesn't necessarily try to solve the hard problem head on. Instead, it asks, what functions does consciousness actually serve? What job does it do for us or any creature that has it? What's the evolutionary advantage?
Right. And this is where the functional view is really helpful, I think. It lets us kind of sidestep those purely philosophical debates about subjective experience that seem, impossible to measure objectively. The source basically suggests that consciousness, including that inner subjective feeling, isn't just some passive awareness state. No, it actually serves vital evolutionary and survival functions. It's like a really advanced toolkit for navigating the world and especially the social world. So let's look at some key functions. First, self-modeling. This is the ability to build and keep an internal picture of yourself as an agent acting in the world, understanding that you are separate, that you have intentions, that you exist across time with a past and a future. It's vital for planning ahead. Then there's attentional control. Being able to direct your focus, tune into important stuff, and filter out distractions. Absolutely crucial when you're bombarded with information. We also see executive function being a big part of consciousness. This covers making complex choices, planning out detailed actions, coordinating different mental processes towards a goal over time. Like being the conductor of your own mental orchestra, making sure everything works together. And then there's the integration of information. Consciousness seems to be where all the different inputs, senses, memories, thoughts get woven together into one coherent, constantly updated experience of reality, like your internal movie. And finally, especially for social animals like humans, there's social cognition. Consciousness really helps us understand other people's minds, figure out their intentions, predict what they might do, navigate these incredibly complex social webs. It allows for empathy, cooperation, even, deception. So yeah, the source really frames consciousness as a sophisticated tool that helps organisms, particularly social ones, handle incredibly complex physical and social challenges, ultimately helping them survive and thrive.
That definitely paints consciousness as this highly evolved utility knife, almost. But for a lot of people, that feeling of being conscious, that subjective meanness, it feels like it's more than just a function. How does the functional view handle that really deeply felt aspect? Does it say the subjective feeling itself is also a function, or is that kind of where this view maybe hits a wall?
That's a really important point. The function perspective doesn't deny that subjective experience exists. It just asks about its purpose. It suggests that the subjective experience, the feeling of being conscious, is itself a highly adaptive function. Think about pain, for example. That subjective feeling of ouch isn't just there for no reason. It's a powerful signal. It motivates you to avoid harm, to learn what's dangerous. That's a crucial survival function. Or the subjective feeling of self allows for that sophisticated self-modeling and planning we talked about, letting you strategize over long periods in a way a purely reactive system just couldn't. So while we might struggle to, put redness under a microscope, this framework says those inner experiences aren't just side effects. They're integral parts of a very complex system designed for navigating reality effectively. They do something vital.
Right. So rather than consciousness just being, like a light switching on with no real job, it's actually busy doing a lot for us. It's like this high-level operating system enabling a really rich, adaptive way of interacting with everything around us. Much more than just simple awareness. Okay, so we've kind of pulled apart life, intelligence, and consciousness, looking at what they do, their functions. The big question now, I guess, is how do they relate? Are they just separate buckets, or do they maybe build on each other, like stacking blocks?
That's a great question, yeah. And it really gets to the heart of how they all connect. From the source's perspective, these functions aren't just related. They seem to be nested, interdependent. They form this kind of continuum of increasing complexity and capability. So, life is the base layer. It provides the fundamental self-sustaining process. It's the foundation maintaining integrity, processing energy, replicating, basic adaptation. Without that basic self-organization and metabolism, there's really nothing for intelligence or consciousness to work with, right? Then, building on that, intelligence seems to emerge as a way for these living systems to achieve goals more effectively, especially when the environment gets more complex and unpredictable. It's like an upgrade, enhancing how a living system interacts with the world, going beyond just slow genetic change. A simple organism might adapt over generations, but an intelligent one can learn and adapt within its own lifetime, much more agile. And then finally, consciousness, at least in its more complex forms, provides these really advanced tools for highly intelligent organisms, especially social ones, tools to navigate even more intricate challenges. It boosts the ability to learn, predict, plan, adapt, particularly with self-awareness and understanding others. That's critical for complex social life, long-term strategy, really tricky problem solving. So yeah, you can definitely see them as building blocks. Each layer adds more sophisticated functions on top of the last, allowing for richer interactions and better chances of success. Which does raise an interesting point. Viewing them this way, as a functional continuum, does it help explain their evolution? And crucially, could you have, say, a highly intelligent AI without the biological functions of life, or does it need some digital equivalent?
It definitely gives a really coherent story, doesn't it? A kind of progression of capabilities. And that's, I think, why this functional perspective feels so clarifying. It connects different fields, biology, AI, even philosophy, using observable actions, not just fuzzy properties. And to your question about AI, yeah, it kind of suggests that even an advanced AI, while maybe not alive biologically, might still need some core lifelike functions to really get complex intelligence going. Maybe digital versions of maintaining boundaries, processing data like energy, replicating code, adapting through learning. It's a really powerful way to think about it. So just to quickly wrap up this really fascinating deep dive, we've looked at defining life by its processes, intelligence by its goal-achieving actions, and consciousness by its tools for navigating the world and understanding ourselves. It offers this remarkably clear, practical framework. It's all about the what, the how, and maybe the why of their existence, viewed through what they do, less about what they are inherently, more about their dynamic capabilities.
Absolutely. And if we connect this to the bigger picture one last time, think about how this functional view might change how we approach AI debates. When we argue if an AI is really intelligent or conscious, instead of looking for something that looks like us, maybe we should look for these functional behaviors. Or consider searching for life beyond Earth. What specific observable functions would you actually look for first if you were trying to identify life or intelligence in a truly alien context? What capabilities would signal it's alive or it's intelligent?
That's a fantastic question to end on. Really pushes us beyond our earthbound assumptions. Well, thank you for joining us on this deep dive into the functional side of life, intelligence, and consciousness. We really hope it's giving you a fresh, maybe more practical way to think about these huge questions. Until next time.